equations. Okay, we want to balance the following chemical equation. I have C4 plus O2, and what it's going to yield, that should be a yield sign and not an equal sign. Let's fix that. So what I have is the reactants on one side of my equation and my product on the other side. Okay. These are going to be the reactants. And these will be the product of the chemical reaction. And what I see is that it is not a balanced equation. The equation must be balanced because I have to conserve mass. There's a conservation of mass law, which says that I cannot lose mass. So the mass that I start with on the left has to be equal to the same amount of mass on the right. In this case, what it's meaning, I can't lose any of the atoms as I go from the left to the right. So first thing I do is use a count to see what do I have. I have 1 carbon, 4 hydrogen and 2 oxygen on the reactant side, and I have 1 carbon, 2 oxygen, 2 hydrogen and 1 oxygen, which gives me a total of 3 oxygen on the product side. So what happens is, on the left I have 4 hydrogen and I have 2 oxygen. On the right I have 2 hydrogen and 3 oxygens. So they are not balanced because I should have the same number of hydrogen on each side, same number of oxygen on each side. My carbons are fine because I have 1 carbon on each side, but it's the hydrogen and oxygen that are not balanced. So looking at the chemical equation again, what I need is a number that I can put in front of my compounds, right, that could possibly balance it, meaning I would have the same number of elements on each side. So I want to be able to balance the hydrogen and balance the oxygen. So I need some coefficient that I can put in here to allow them to be balanced. I cannot change the subscripts. Okay? The subscripts are fixed by the reaction, and I cannot change these. Okay? By changing these, it changes the reaction. It changes to something totally different. Okay, so the subscripts are fixed, but I can put as many different coefficients in there that I want to. Okay, so what I decided to do is put a 2 in front of the oxygen on the left side and put a 2 in front of the water, the H2O, on the right, and then count again. Okay, what I end up is I still have the 1 carbon, which is fine, but now I have 4. I still have my 4 hydrogen and I have 4 oxygen. Okay, because the 2 oxygen in the front and the 2 subscript, multiply those together, tells me that I have a total of 4 oxygen there. Okay, on the right side I still have 1 carbon, so my carbon is still fine, and I have 2 oxygen from the CO2, but now I have 4 hydrogen because I have a 2 in front of the H and I have a subscript 2, so that's 2 times 2, that will give me 4 hydrogen. Now what I've also done, since I put this 2 in front of this H2O, I now have 2 oxygen, okay, because I have a 2, and since I have no subscript written here, it's a 1 actually. So we don't write the 1, so what I have is 2 times 1, which is 2. So now I have 2 oxygen from water and I have 2 oxygen from the CO2, which gives me a total of 4. Okay, as we said earlier, the carbons were fine. Now I look at I see the hydrogen is fine. I have 4 hydrogen on the left, I have 4 hydrogen on the right. And now I also have 4 oxygen and 4 oxygen. So now the equation is considered balanced with a subscript of 2 in front of the oxygen molecule and a coefficient of 2 in front of the water. Okay? So let's look at one more example. It's coming from your book. This problem is another reaction where I have a P2H2 and it's going to yield PH3 plus P subscript 4. This is now unbalanced, and let's start by counting what we have. I have 2P phosphorus on the left and 2 hydrogen, whereas on the right I have a total of 5 P's and 3 hydrogen. So it is unbalanced because I have 2 on one side and 5 phosphorus on the other, whereas I have 2 hydrogen and 3 hydrogen on the other side. Okay? So my left and right is not balancing. So again, I want to look at the equation, and what I need is a coefficient that I can put in front, which would give me equal number of phosphorus and hydrogen on both sides. Again, I cannot touch the subscripts here, but must take them into account when I put the coefficients in front, because I have to multiply by these numbers. Okay? So let's see. So let's try a 3. If I put a 3 in front of the first one on the left and a 2 on the PH3 on the right, let's count to see what we have. Okay. The 3 in front of here gives me 6 phosphorus. 3 times 2 will give me 6, and it will also give me 6 hydrogen. 3 times 2 will give me 6 hydrogen. So now I have 6 phosphorus and 6 hydrogen on the left. And if I count on the right, I have 2 phosphorus, and then 2 times 3 will give me 6 hydrogen. Then I have 4 phosphorus, and I add those together, I get a total of 6 phosphorus on the right, 6 hydrogen, and I now have 6 and 6 phosphorus, 6 and 6 hydrogen. So this equation is now balanced also. Okay. Balancing equations, you have to continue to play with the coefficients in front until you get the correct answer. Okay. Again, with the goal of getting the same number of elements on the left as you have on the right to be able to conserve mass.